All right, good morning, everyone. Thanks very much for getting in here nice and early, 9 a.m. on Thursday to come to this session. My name's Nick Ward. I'm an Azure Technology Specialist for Microsoft. And today we're going to be talking about Azure as a platform for running your applications. In particular, from the perspective of microservices. Most customers' conversations that I'm having today involve microservices. It seems to be a very popular approach that applications are being built via, all wrapped up with an API facade for communication between the microservices that make up the application. So this pattern is becoming quite a standard, and there's a bunch of different ways that you can implement microservices with an API facade in Azure. And so that's what this session is about. It's about what are my options and what's the best approach. What's the best set of technology in Azure for implementing this type of application in Azure. So we're basically going to be talking about this slide for the rest of the session. There's going to be a fair bit of demonstration on how all of this works. So I hope by the end of this session you'll have a good sense for which one should I use and a little bit about how each one works. So this picture kind of shows you your options for implementing microservices in Azure. Just to do a quick check, how many people are familiar with the microservices pattern in the room? Okay, probably about half, maybe a touch over. So just very briefly for perhaps those that aren't, the concept of microservices is breaking down the traditional monolithic approach to building an application, where we build an entire application, user experience, application tier, database tier, or data tier, for a complete application. Breaking that approach down into its constituent parts. What are the bits that make up this application? Is there a customer bit? Is there a product bit? Is there an order bit? And implementing those bits as self-contained microservices. So we have the customer microservice, we have the product microservice, we have the order microservice. And each of these are totally self-contained from a technology perspective, from a data perspective, from an access and management perspective. They're all completely self-contained. The idea being that we can iterate and move a lot faster than we can with a monolithic application. When everything is in one big app, we want to make one little change to, let's say, the definition of a customer. That has ripple effects all throughout that large application. So there's a lot of regression testing, there's a lot of extra overhead work that we need to do to make sure that that little change doesn't break everything. So it makes for a very brittle application that can't change very quickly over time. Microservices, on the other hand, the promise is that because each application component is self-contained and quite small, if we want to update the definition of customer, well, we're just updating it within the bounds of that microservice, so that should be a much faster operation. As long as we're still meeting the contractual obligation of the microservice, still providing the same information out if and when it's asked for, then nothing else in the ecosystem of applications should break. So we have a much more resilient, much more agile pattern to build our applications. That doesn't do justice to microservices at all, but hopefully it's a little introduction for those of you who are relatively new to this concept. So in this diagram that I've got on the board, hopefully you can see, it's fairly faint on this projector. Can you see the dotted line squares that surround here? No. Okay, I'll use your imaginations. There are some dotted line squares around the right-hand two icons, around the next two icons, and then around the next one and the one on the bottom left. Each of these boxes that do exist, trust me, essentially represents what could be a microservice. And each icon represents a different technological option for implementing that microservice. So in Azure, the common ones that I tend to talk to developers about, and I come primarily from a platform as a service perspective, are the serverless options that we have with Azure Functions and Azure Logic Apps. Serverless is a term that's come to refer to a platform as a service option where you don't have to worry about the server that's running your application. It's essentially, from the developer's perspective, it's serverless. I have a name of a little application component, and I have some code. And that's all that I worry about. I create a new name, I create some new code with that name, and it runs. If I call that code one time in the next year, well, I'll pay for one execution in the next year. If I call it 10,000 times in the next hour, well, I'll pay for 10,000 executions, but I don't have to worry about scaling it up, scaling it out, scaling it back, or any of that, because scaling is a server concept, and I don't even know that there's a server here. I just have a little application with a piece of code and a name. Azure Logic Apps is very similar to that. Logic Apps is a workflow system that we have, where again, you don't need to worry about the server infrastructure that workflow is running under. You just worry about what is the definition of your workflow. And that typically calls REST APIs. It orchestrates REST API calls, perhaps with some if this result, then do that type logic, some looping constructs and so forth. But again, it's serverless. We don't need to worry about the server infrastructure that's sitting underneath it. So, very productive environment to the right-hand side of this slide. Really, we don't have to worry about the infrastructure that's running these applications at all. We just worry about the code that we want the application to run. Moving slightly to the left, we've got Azure App Service, API apps, and mobile apps. This is more of a well-known, well-understood pattern for implementing server functionality. So using ASP.NET Web API or MVC, implementing a REST API-based server component, using Java, using PHP, using whatever language you like out of a set of several. I do know that this code is running on servers, and I do have the ability to scale out that server infrastructure and scale it back. I can set up auto-scale rules around that. I have a little bit more control and a little bit more management to do of the environment that's underpinning my application, but it's still a reasonably high-level platform as a service. I don't need to patch the operating system. I don't need to worry about high availability. I don't need to worry about routing network traffic for failover and all of those sorts of things. That's all handled by the platform, but I do have a little bit of management control over the server infrastructure that's running my application. So we're getting a little bit more control, and we're taking on a little bit more responsibility for the running of the application. Then we move to something like Service Fabric. Service Fabric is an Azure service that we have, although it also runs on just any Windows Server VM or set of VMs. And we've introduced Service Fabric for Linux as well, so it can essentially run anywhere that you can run Linux or Windows Server. So it could run in competitive cloud offerings, it could run on-prem. Service Fabric is a framework for building microservices applications. That's not to say it's the only way to implement microservices in the Microsoft stack. All of these options allow you to implement microservices. Essentially, microservices is a pattern of implementation. It's just that with Service Fabric, we've deliberately built the framework with microservices in mind. So there's a couple of capabilities and features in it that are really quite nice when you're implementing this type of application. However, you are taking on more control and responsibility when you move to a Service Fabric style of application. You do have more decisions to be made about the operating system. You do need to patch it. You do need to look after it a lot more than you do with the services on the right-hand side of this slide. One of the things I find, particularly with our marketing approach to this, particularly within the context of microservices, if you read our marketing documentation and say, haha, I want to do microservices, azure.microsoft.com, what should I use? The answer that comes back at you is Service Fabric. I would argue that that's not correct. It's not a full and accurate answer. Yes, Service Fabric is a platform for you to build microservices on, but it's not the only one, and it's not necessarily the best one for you. We've built Service Fabric specifically for large-scale ISVs. In fact, we've built it for ourselves. We built Service Fabric to run aspects of the SQL Azure database, aspects of Skype for Business, Cortana, a number of the very large cloud-scale services that we run. If you're similarly looking at building a very large-scale cloud service, then Service Fabric may well be a fantastic technology for you to use. But if you're an enterprise developer looking at more of an employee-facing app, or maybe it's a customer-facing app, but reality is we don't have hundreds of thousands or millions of users all using this service simultaneously, I would put to you, do you really need the added control and responsibility for those added features that Service Fabric brings? I'll go into this in more detail, but it's just I guess a myth I see a lot, that if I want to do microservices, I need to use Service Fabric. I would say there's a lot more to it than that, and it's not necessarily the right answer for every application. Now, moving further to the left, you've got Azure Container Services. So containerization is certainly a very popular method for implementing microservices, and it's one that we absolutely support in Azure. In fact, you can even implement microservices in virtual machines if you want. It's not necessarily the most efficient way to do it, but you certainly could. I'm not going to be talking about containers and virtual machines in this session. I'm going to be talking about primarily the differences from functions to Service Fabric and what your options are, going into more detail in those elements. Regardless of which one you do choose out of this layer of options that you have, we have a service called Azure API Management, which I highly recommend that you have a look at. Because this approach of microservices says that each application exists independent, or each microservice exists independently of the next, the question becomes, how do they talk to each other? One option is they just call each other directly. I would urge you not to go down that approach. The challenge with services calling each other directly is you can very quickly end up with a whole bunch of spaghetti. If you want to change the platform that one of those microservices is operating on, you'll have to change all of the clients of that microservice to point to the new platform. Whereas if we have an API facade, an API management point, where all of our microservices are being advertised to, if I change the platform that the microservice is running on to something different, I just advertise that new platform to the API facade, and all of the clients of the API don't need to know anything's changed underneath the covers. You could have completely changed it from running on, let's say you chose Azure Functions for your microservice, and you were very happy with the first version, but then you realized actually we need a little bit more control over our application here. We want to move to API apps to run this microservice. With an API facade in place, you can do that and just point the API facade at the new API apps implementation of your microservice, and all of your clients of that API that are hitting that API facade don't need to know that you've actually moved from Azure Functions to Azure API apps. They can still just call the same endpoint with the same call, and the API facade routes that call through to the appropriate location. So the API facade, the API management piece, really helps deliver on that promise of loosely coupling these microservices. If we have them calling each other directly, I'd argue that we're actually somewhat tightly coupling those services together by endpoints and domain names and potentially ports and those sorts of things. So sitting on top of this infrastructure, once we've got our set of microservices with an API facade in front of them, the question becomes, how do we build applications on top of that? I'm not going to go into detail on that in this session, but suffice to say you can build websites that access that API facade, you can build mobile apps that access that API facade, We, of course, have great technology for building and running those web and mobile apps. We also, from a pro dev perspective, Xamarin for mobile apps, and of course ASP.NET, Visual Studio, etc. For the websites. We also have a set of business user tools to build mobile apps and workflows as well. Quick show of hands, how many people have heard of Power Apps? Okay, just a couple. Power Apps is an Office 365 service that allows business people to build mobile apps, much like you would build a PowerPoint presentation. Instead of building slides, you build screens of your app. And much like Excel, you can connect those screens to back-end data sources, to REST APIs, to API facades, to light up those screens with data and allow the user of that mobile app to interact with the data. So Power Apps is a way for business users to build mobile apps. They can share those mobile apps between other people in the organization. They run on iOS, they run on Android, they run on Windows, so they don't need to worry about different platforms. They don't build professionally developed applications. Power Apps is not a professional development tool. It doesn't publish apps to the store, the various store platforms. It uses the Power Apps platform or the Power Apps app running on each of those devices to run the application, much like PowerPoint on each of those devices runs the PowerPoint deck. So it's not a pro dev option, but it is a useful business development option for that long tail of mobile app requirements that you're never going to get around to from a pro dev point of view. There's just too many requests. Similarly, Flow. How many people have heard of Microsoft Flow? Just a couple. So Flow is a business user tool, again as part of the Office 365 suite, that allows business people to build workflows. So I mentioned before Microsoft Logic Apps, which is our tool for building workflows in a platform as a service mode. Microsoft Flow is essentially Logic Apps, but with a business user UI, something that's very Office 365 friendly. So we have those options: professional dev, business user dev for building front ends to this set of APIs and set of microservices that you're building on the underlying platform. All right, so let's make this real. Of course, you have the whole DevOps conversation around this, which I won't be going into detail, but there's been a number of other sessions at Ignite this week on DevOps and how to deliver all of this application capability. Don't forget analytics as well. All of your microservices are going to be producing a whole bunch of telemetry about what's happening in your business. And so there's a whole bunch of analytic services that we have to take in all of that telemetry and make sense of it. And then, of course, there's the ongoing management and operations of the platform itself to make sure it's healthy, it's up, it's running. What I'm going to show you now is an implementation of this architecture. So we're going to see a couple of things. We're going to see a range of microservices implemented in everything from functions, logic apps, an API app, and Service Fabric, with an API management facade sitting in front of all of that. And I've got a web app and a mobile app that then looks at that application capability. The scenario is a task system, nice and simple. So I've got 3 microservices in my task management system. I have, in my API app, I have a task microservice that allows you to create tasks, complete tasks, delete tasks, etc. I've got a notification microservice, which allows you to send notifications when a task completes. So it sends emails, it sends push notifications, and there's also an option to send both in the case that a task is urgent and you've completed it. Then we send a push notification and an email to say it's been completed. So I've got my task API, my notification API, and I've got a project service fronted by a project API. The project service collects multiple tasks together into a unit called a project. So let's have a look at what this looks like in reality. So just to show you what the system essentially looks like, very simple web user interface to what's going on. I can see what my active tasks are. I can see what my completed tasks are. I can add a new task. Let's say present something. How's that text size, by the way? Can people see it at the back? Yeah, excellent, great. So I hit create, and I've got a new task that says present something. In fact, if I say do something urgent, and then I complete that, then theoretically, with a little bit of luck, we should get a push notification to say that that task has been completed. Might take a couple of seconds for it to flick on through, but that notification service has been executed to make that call. There we go. So do something else urgent has been completed. If I go to projects, I can see that I've got a bunch of projects. If I go into my A project, I can see that I've got a bunch of tasks associated with that project, and I can add some new tasks to that project, and I can go back to my list of projects, and I could indeed complete a project. So pretty straightforward application, but underneath we've got these three microservices, these three API-fronted microservices implementing those tasks, those projects, and those notifications. So let's have a look at what that looks like from an API level. So what I'm looking at here is Azure API Management. API Management, as I mentioned before, presents a facade across my APIs, across my microservices that I am publishing. We can see here I've got my notification API, I've got my project API, and I've got my task API. And I've got a little bit of statistics here on calls that are being made. I can see how many calls, I can see errors, bandwidth, response time for my API as it's being used. If I look at this from a developer perspective, one of the really nice things about Azure API Management is it gives you a developer portal for developers to interact with your API. You can securely advertise this externally to your company, maybe not your whole API, maybe just parts of your API. You can use it internally as well. So if I go to my list of APIs here, I can see I've got my notification project and task API. If I go straight to my notification API, I get some nice functionality like the ability to try it out. I get information on how to make a call to that API. I get some code for various different languages on how to call this API from different applications. And I can go ahead and try it. So let me try the send the push notification actually. If I do that and hit try it, I get a little user interface to actually try out this push notification. So give it a task name, something with an exclamation mark. Let's hit send. I get a 200 response and I get my push notification sent. So nice, easy way for developers to understand your API, to interact with it, to try it out, to get documentation, to embed your API into their code. Again, this is relevant whether you're talking internally or externally advertising your API. The last thing I'm going to show you on API management is the ability to front different APIs or different back-end REST calls with a common API. So one of the things that we see about this, let's say, notification API, is that it presents three very simple, straightforward operations. 2 posts and a get, send task complete email, send notification, send push notification, all with nicely formatted parameters that it's expecting. Challenge is though, each of those 3 API calls are actually sitting on different technologies with different REST API endpoints with different expectations of how the parameters get passed. Some of them expect the parameter in the URL. Some of them expect the parameter in the body. I don't want to present all of that complexity out to my developers. I want them just to see one API call with a nicely uniform set of calls or operations that they can make against my API. And the secret of that, in terms of Azure API management, rests with the policies. So if I select my notification API and my send task complete notification, let's go full screen and configure policy. What you can see here is I'm rewriting the URI. I'm setting a different back end. I'm setting some header values. I'm setting some body values. In the body, you can see that I'm actually getting some information out of the URI parameters and injecting it into the body. So essentially what I'm doing here is I'm taking an incoming request that is formatted one way, I'm pulling apart that request, the URI, the parameters, and the body, and I'm reconfiguring it to what the back-end API actually expects. And this is what gives me the power and control to have whatever I want on the back end, but present a nicely unified set of API calls to any developer that wants to access my application. If I move that back-end service from whatever it's sitting on today to something completely different tomorrow, I can just update my policies here to point to that new service, and none of my clients for that API need to know anything different. They'll just be routed through to that new API backend. So a bunch of great capability in Azure API management there. Let's have a look at the back-end implementation of some of these components, and let's start with looking at how I've implemented the notification microservice, the project microservice, and the task microservice. So in amongst my resource groups here, again, just a quick font check at the back. Can you guys roughly see this? Thumbs up? Great. So 3 resource groups in particular I'm going to draw your attention to. I've got a notification resource group, I've got a project service resource group, and I've got a task resource group. These 3 resource groups represent my 3 microservices: notifications, tasks, and projects. If I go into my notification resource group and have a look at the things that are in here, again, this is talking about sending notifications, email, and push notifications out to users when tasks get completed. So we can see a couple of things here. The first is that all of the assets in the resource group make sense at a business level. I could actually have a conversation about this resource group with a set of business people and they wouldn't be too confused. Why? Because I've got things like a logic app, or let's call it a workflow, that sends a task complete email. Okay, that makes sense. I've got one that sends a task complete notification. Okay. I've got the next are my notification hubs. They're the service in Azure that actually sends out the push notification to the mobile devices. Okay, so I've got a push notification service that actually does the push for me. I've got an Office 365 connection that's used for sending emails. So I'm going to send my emails via Office 365 Exchange Online. And then I've got a function which, well, perhaps that naming standard is not particularly useful for a business user, but if I called that function something better like send push notification, which might have been better, then that would make sense. I've got a function that sends a push notification. But essentially, they're all assets that make sense from a business point of view of what it is that I'm implementing. Let's have a look at the send task complete email, for example. So this is a logic app or a workflow that sends emails when I complete a task. And if we have a look at the design of this, it's really quite simple to understand. Remember, we're at the right-hand side of the set of options here. We've got a lot of productivity with this option. So here, I accept in a web request. Basically, I expose a REST API. So I accept in a REST, an HTTP post to this URL. This gets allocated by logic apps. I'll show you that in a moment. I've specified a body that I expect to receive with this REST API call, and in this body, I expect to receive a task ID. So what's the ID number of the task for which we're sending an email? Once I've got that task ID, I can then call my API management facade and call the getTask operation to get the details about that task and just pass in the task ID, and then I can send an email to whoever that the task has been completed. Just going to copy that value for a moment because I want to show you how simple these things are to create. So let's create a new logic app, and let's call it Ignite NZ Demo, and I'll put it into a new resource group called Ignite NZ Demo. And let's run this in Australia East. And I'll click create. That'll just take a quick moment to submit that deployment and create my logic app. While that happens, I might just flip over to functions. Oh, actually, it's already completed. So let me go to it. That was pretty quick. So go to my Ignite NZ Demo resource group and have a look at my new logic app here. And I can go straight into the designer experience. We have a bunch of templates, bunch of workflow templates that you can pre-select from. We have integration with a whole bunch of first and third-party cloud services like Dropbox and Twitter and Office 365 and a whole bunch of options, and the list keeps growing. But I'm just going to select a blank logic app. I'm going to accept just a request, an HTTP post. Pretty simple. The URL will be generated after the save. Okay, great. That's all I have to do. I've now exposed a REST API endpoint for this workflow. Let's put a new step. Let's add an action. And let me click this little down arrow and say, show API management APIs in my subscription. So here's my API that's managed by Azure API Management that we just saw before. And of course, I get my notification API, my project API, and my task API. So I could now select my notification API, and I could say send task complete push notification. It expects a task name to be provided through. It's getting all of this information from the same source as my API management instance and the portal I was using before, the API management developer portal. So I can give a name. I've done something else. Subscription key, that was that value that I copied before. The API management facade is secured by a subscription key, which is unique to me as a developer. So I'll add that in. I could put some additional steps here. I could even put conditions. So I can access content that's available to me from previous steps in my workflow. I can inject those here. I can test for conditions once I do that, and branch off in different ways for my workflow. I'm just going to remove that step. Click Save. And now, essentially, I've just built a little wrapper around my send task complete push notification that sends a notification for the something else task. Pretty trivial example, but think about it in the context of I've got a separate set of API requests that do some things. I might want to aggregate them together or put some logic around those existing API requests and expose that new logic as an API itself, as a new microservice or as a new element to an existing microservice. I can do that very, very easily with logic apps, just by pointing and clicking and accessing the various APIs that I've already got exposed. I can also go to the code view here. Everything that you do in Logic Apps is basically building up this JSON configuration file that declaratively describes what the workflow is to do. So this is all that's really being created here behind the GUI designer, is a JSON file that you can edit directly and update your workflow definitions. This also can become part of your Azure Resource Manager template, your ARM template, if you want to automate the deployment of these workflows. This essentially is the ARM template for a Logic app. All right, so that's a little bit about Logic Apps. Very productive, fast way to build APIs and to build workflow-oriented logic. Let's go back to the notification resource group, because inside that I've also got a function. So let's have a look here. A function, as I mentioned before, an Azure function is little more than a name with a piece of code. In this case, I've got one name called task push notification function, and I've got a bit of code associated with that. So this code is a piece of Node.js code, and all it does is it imports the Azure Service Bus function. It then interacts with that capability to send a toast payload to the Azure Service Bus or Notification Hub's service in Azure. So the function really just wraps the push notification service in Azure to call it with a particular payload, so that we get that payload sent to the user. Question? Do you have a choice of language? Yes, you do have a choice of language. There's a variety of different languages that we support. It is in preview today, so the list of languages is somewhat restricted today. But you've got Node.js, you've got C#, PowerShell's either there or coming. Java, I think, is there or coming. Python is there as a preview. So there's a bunch of different languages and more on the way. I get a little interface here that I can run this task, but let me create a new function to show you what the process is to create a brand new function. So here you go, language options. What have we got today? Bash, Batch, C#, F#, JavaScript, PHP, PowerShell, and Python at the moment. And there's a few more on the way. So let me have a look at HTTP trigger. This is interesting. I just looked at this a couple of days ago, and we've changed the options. Oh, unless it's all. Yeah, here we go. So let me have a look at HTTP trigger Node.js. That'll let me. So I'm creating a simple HTTP trigger based function. So it's going to be executed similarly to my Logic app via an HTTP request, and it's going to run a piece of Node.js code. And it's pretty simple. It looks at the parameters in the URI or the body, and it pulls out a name and says hello name. We get a little interface where we can let's save that. And let's run it. Let me just minimize down a little bit so I can see what I'm doing. So if we run it, we can see that the function completed with success, and we should get output. And it's really interesting because I did this demo a couple of days ago, and we've updated the UI, the user experience. So I'm not exactly sure where we've put the output. Anybody know? Normally somebody in the audience has gone, oh yeah, we just updated it 24 hours ago. Keep scrolling down. No more scrolling. Anyway, we'll move on. The output that you would see is hello, so-and-so, or if we didn't pass a name, which we didn't, then simply please pass a name on the query string. But this is just a request to this URL, so if I just put that in, we should see, please pass a name on the query string or in the request body. And so if I say name equals Nick, then we should see hello Nick. Trust me, we really should. All right, let's carry on. At least we know my push notification function is working, right? But that's essentially what notifications are about. Simple piece of code with a name. I execute it once, I pay for one execution. If I execute it 100,000 times, then I pay for 100,000 executions. But beyond that, I don't really need to worry about it. Logic apps and functions, I can wire up to HTTP requests, which is what I've shown you. I can also wire them up to queues, so they execute every time a message goes on a queue, the function or the logic app fires. I can wire them up to blob storage. I can wire them up to a whole bunch of different input and output services so that they trigger at different times or at different events. Of course, both can be scheduled as well, so they just execute at a particular point in time. So I think functions and logic apps are critical, increasingly critical for functions, and certainly critical in the terms of logic apps to most applications that are being built today. Let's swap gears a little bit and have a look at my task resource group, which implements my task microservice. So here we have a couple of different assets to look at in this resource group. So to implement my task service, I have at the top an application insights service. Application insights is an Azure service for monitoring an application from a developer's perspective. So you get to see how many times is my application being called, what's the response time, all sorts of insights into how your code is performing. I've got a database which stores the state for all of the tasks in my system. I've got an app service plan. An app service plan is much like a mobile phone plan. It's a billing point for all of my API apps, web apps, mobile apps, and even logic apps and functions that I might want to run within my application. So a plan essentially gives me, a charge per month, and then I can run as many API apps, as many web apps within that plan as I want to. The free tier has some restrictions. I think it's limited to 10, but once you get up to a standard or a premium plan, you can run any number of websites, any number of API backends that you like within that plan, and just pay each month for the plan and the amount of resources that the plan used. You can either auto-scale the plan, or you can manually scale the plan, or you can just have the plan at a fixed allocation and you'll pay the same amount every month for that plan. And we bill by the minute or very small period of time. So as you scale out and back, you'll just pay for whatever it is that you're using at that point in time. And then lastly, in my resource group, I've got the service itself. So this is the actual API, the actual API app that's running my code. In this case, it's an ASP.NET Web API application that is exposing create task, delete task, complete task, all of those sorts of functions. Now, one of the nice things about app service is I've mentioned web apps, API apps, and mobile apps. It turns out each of these three things, you might have heard these terms before, web apps, API apps, and mobile apps. Turns out they're all exactly the same thing. They're all a container for running a piece of code, which is the same as what a function is, right? But a function is restricted more to one function, whereas an API app, a web app, a mobile app is any traditional API or website that you want to deploy. Very familiar coding approach here, very familiar standards that we support. And indeed, it really is just any old website that you've got, whether it's just an API backend, whether it's the HTML front end, doesn't really matter. It's just a web hosting environment at the end of the day. So any web hosting requirement that you have can pretty easily be satisfied by an API app or a web app. Let me show you creating a new one, and actually I'm not going to create from there, I'm going to create from here. Let's create a new, I'm going to create a web app, but remember a web app is an API app, which is a mobile app. They're all exactly the same thing. They just have, well, they're exactly the same thing. So let's call this Ignite New Zealand Demo 1. And let's put it into my Ignite New Zealand Demo resource group and hit create. So much like I created a new logic app before and a new function, I'm now creating a new web app or a new API app. That'll take a couple of seconds, but it will end up with a place at which I can deploy any of my web code to. So this could be an ASP.NET project, could be a Java project, could be PHP, could be Node.js. Again, there's a bunch of different languages that we support, but it's a fully managed environment. Yes, there is an operating system sitting underneath this, but I don't need to patch it, I don't need to manage it, I don't need to worry too much about it, other than how do I want to scale it? What size VM do I want running my service? And how do I want that VM to scale out and back? So I do have a couple of points of control around those types of things. So that's succeeded. Let's have a look at my list of API apps here. Ignite New Zealand Demo. So this has now been provisioned, and I can see if I browse to it that the web app's been successfully created. It's basically a placeholder page sitting there at the moment. But I can go down here to deployment options. And one of the things I really like about API apps and web apps is I can deploy from an existing source code repository where I've got my, my code sitting. So I happen to have some code sitting up on GitHub that I'm going to connect this web app to. Choose the project that I want to connect to. I'm going to connect to my bakery site project and click OK. The web app service is now going to GitHub, dragging down my code. It's going to build it and deploy it onto itself and then have it available for me to access and use. So that's successfully set up the deployment source. If I go back to the deployment tab, then I should see it in process. So it's fetching the code from GitHub and then it will start building it and making it available for me to use. So again, any web code that you've got sitting on GitHub, you can just wire it up to a web app, it'll drag it down, deploy it and start running it for you. So anytime you need a web hosting environment, just hit new web app. A couple of seconds later, you've got a new web hosting environment that is fully patched, fully managed, 99.95% SLA available. Auto scale out, auto scale back, huge amount of capability provided in this service out of the box. So that's now provisioned and it's active. So if I browse to that again, we should, instead of the blank placeholder page, we now see my website, which has been dragged down and is running now. One of the other things about this web app environment that's really, really useful. I mean, there's a whole bunch of features here that I don't have time to go through all of the capabilities of the service with you today. But just to mention one of the particular highlights I like is this thing called deployment slots. I can create, on the standard plan, up to 5 slots, on the premium plan up to 20 slots. And each of these slots is essentially another environment that I can deploy code to. So I'll create a slot called staging. Very common to have a QA slot, a staging slot, maybe a B slot, any number of different slots for different purposes. Once that slot gets created, so I've got my staging slot here, what you'll see here is essentially another web app. It's another environment, but it's tied to my initial web app environment. So I can do a couple of really interesting things here. One of the things I can do is swap the environments. So if I promote my code to the staging slot and I do all of my tests, I can now swap my staging and production slots to promote my code into production. And it takes just a few seconds to do it. There's no outage or downtime from the user's experience, and I've upgraded my site. If I have the oops, oh no moment, I need to roll back, well, I can just swap them again, and I go back to what production used to be. We also have this concept of a swap with preview, which does like a 2-stage swap. The first thing it does is it takes the staging environment and swaps the configuration variables. Because you probably have a bunch of things like connection strings and so forth that are different in staging and production. So the swap with preview changes all of those configuration environment variables to the production settings. Then you can do all of your last tests and so forth, make sure it's all right. If it's still okay, then you hit the swap button again and it actually does the swap. So you get that last test with the production settings before you actually promote it to production. One thing you can also do, which is really useful around deployment slots, is let's go to traffic, testing and production. So now that I've got 2 slots, I might have my next version promoted to my staging slot, let's say. And now I've done all of my tests. I've updated the configuration to be against the production database. So I've got my staging slot and my production slot both against my production database. I can do that independently of the swap. So let's say I've got that now, but I don't want it to fully go into full production yet. I just want 5% of my client traffic to go to the staging slot. And this will now, after a couple of seconds, unless, what happened there? I've got to actually choose which slot. So production, I want 95% of my traffic going to, and just 5% going to staging. And so now what it's going to do, after a couple of seconds, it'll just start routing 5% of my traffic through to my staging slot, or I might want to call it my B slot, because I can create 5 of these. I can have a whole bunch of them. Route 5% of my traffic to my B slot, get all of my telemetry out of that. If I'm very happy, then swap it to production and route 100% of traffic back to production. Or if I'm happy but I'm not fully convinced, I can up it from 5% to 10%, 10% to 20%. Now 20% of my traffic is going to my staging slot, still monitoring the telemetry, making sure that it's all okay and running well before I promote it 100% to production. So we get a really nice ability to promote code into production out of the box with Azure App Service. Again, we're down the right hand, we're sort of in the middle of the slide that I presented before. In fact, maybe if we just have a look at that for a moment. So we're still at a reasonably productive level of usage, fairly high platform as a service. But let's take a leap to more control with Service Fabric. So if I go to my project resource group, then we'll see my Service Fabric cluster. Now immediately, one thing I just want to point out here is we're thinking about things at a more detailed level now. You can see I've got assets in this resource group like virtual machines, load balancers, public IP addresses, virtual networks, service fabric clusters, storage accounts. So I'm thinking about virtual machines, I'm thinking about networking, I'm thinking about IP addresses, I'm thinking about load balancers. This is a more detailed, I've got a lot more control over how all of this works, but I've also got more responsibility to manage and maintain this over time. If you're implementing a large-scale microservices application, cloud scale, you want this control. You don't want to give up that control to somebody else. You want to keep that control. And there's a whole bunch of capability in Service Fabric that's really useful in that scenario. Let's go into my Service Fabric cluster itself and have a look at what we've got running. So we've got 5 VMs running my project service. Let's go to the Service Fabric Explorer and see what those 5 nodes in my cluster are actually doing. And we can see that I can view my cluster by the applications that are running on it, by the nodes that are making up the cluster, or the system applications. So there's a variety of system applications that essentially make up what Service Fabric is. Service Fabric is a bunch of VMs with these applications running on it, which know about all of the nodes in the cluster. It allows you to submit a piece of code to the Service Fabric cluster, and it will do things like, node 3 hasn't got a lot of load on it at the moment, so I'm going to take that application and deploy it onto node 3. Now I've got my application spread on my 5 nodes. Node 1's running really hot. I'm going to take an application off node 1 and put it onto node 4, because node 4 is pretty cold. It's going to rebalance the load across the cluster dynamically. It allows you to deploy your application. In this case, I've got my project service, that is my application. And there's 2 components to it. There's a web service or a REST API interface to my project service, and then there's my stateful service. And this talks to one of the real power capabilities of Service Fabric. It has an entire state management model built into the Service Fabric framework. So if you build your application, and right at the moment we support .NET and Java, if you build your application to the Service Fabric framework, you can create what we call stateful services. This is a programming model where the state of your objects is maintained in memory with the object. We don't have to write out to an external state store to manage the state of our objects, like a database or a NoSQL database or blob storage or whatever it might be. The state is maintained in the application running at all times. Now wait, you say, if I do that and I lose a VM, haven't I got a problem? The short answer is, normally, yes you would. With Service Fabric maintains multiple primary and secondary replicas of all of your objects as they exist throughout the Service Fabric cluster. So if we lose a node within the cluster, then Service Fabric will automatically route any requests for the objects that were primary on the failed node through to a new primary on another node. And it will do it intelligently to say, well, you know, which ones are hot, which ones are not, and redirect your traffic accordingly to pick a new primary on a node that wasn't running quite so hot. So we can see in terms of my stateful service, we can see a whole bunch of GUIDs here. And trust me, there's 26 of them. Because what I've done is I've partitioned my project service into 26 partitions. This allows me to scale out to 26 nodes and have a separate partition running on each node, but also scale right back down again when the load is not so great. And Service Fabric will allocate my partitions of my service onto the appropriate nodes as I scale out and as I scale back. Again, if I'm dealing with hundreds of thousands or millions of active instances of objects, then this becomes hugely powerful. There is no latency to the database. I don't have to scale a database tier to support my hundreds of thousands, my millions of active objects. Service Fabric maintains all of that for me. It also has a rolling upgrade capability, which I wanted to show you, but I'm running short of time, I'm afraid. If anybody's interested in seeing that, please come up afterwards. I'm more than happy to spend some time showing you how the rolling upgrades work. But essentially, it upgrades, in my case, the different partitions in a rolling fashion. And once it's upgraded the first partition, it waits to make sure that everything's okay. There's a whole bunch of health checks that you can build into your code to report to Service Fabric. I'm okay, everything's running well, or oops, no, I'm not running well, something's wrong. Service Fabric will automatically monitor this rolling upgrade, and it upgrades the first instance, monitors it, okay, everything's okay, let's upgrade the next node, monitor it, everything's okay, let's upgrade the next one, we got a problem, I'm going to automatically roll back that upgrade, back to the state which your application was before you started the upgrade. For zero downtime environments, 24/7, 365 days a year type services, this is hugely valuable to have these automatic rolling upgrades with automatic rollback when the health of the application starts to fail. So state management, rolling upgrades, automatic balancing of load across the different nodes in the cluster, all really, really useful capabilities of Service Fabric. However, what I'd like to finish on is, what should you use? So out of all of this, what's the answer? What do I use? And so in conversations I'm having with customers, I think the answer looks like this, and invite you to challenge me on it, because we're out of time. That's convenient, isn't it? You can challenge me after I'm off stage. It's the green options. So essentially, API management, I think, is critical. The CDN, which we didn't really talk about, but the content distribution network, really, really useful. By all means, have websites and mobile apps. Those layers are pretty straightforward. They make sense. To run your back-end services, I think by and large, start with an API app or a web app. It uses the same code that you've been writing for years. It uses the same patterns that you've been writing for years. You can get to grips with it very, very quickly and easily. As you saw, it's just a matter of saying new web app, deploying your code, running it. I've got deployment slots, I've got traffic routing, I've got backups, I've got all sorts of things that just happen in my environment. So I would say 9 out of 10 conversations I'm having, it's really around web apps and API apps. It's familiar and it makes you way more productive than you've been before. Have a look at the serverless environment. Certainly for logic apps and any workflows involved in your application, really, really useful. Functions do require a different pattern of application development. Each function should do only one thing. So you need to start thinking about your application broken down into tiny little components, which are called functions, and implementing those accordingly. So I'd recommend you start looking at that, but be aware it is a different paradigm that you're moving to with functions. I have not highlighted Service Fabric. I think for the vast majority of requirements, Service Fabric is overkill. But if you are looking at building a cloud scale, very highly scalable, hundreds of thousands, millions of objects all active at the same time, and you need it to be up 24/7, then Service Fabric solves a whole bunch of problems that you're going to run into in trying to run that sort of environment. So if you are at that scale, absolutely Service Fabric is a great technology to be looking at to solve that problem. But if you're not, then I'd suggest maybe look at web apps, API apps as your starting point. Okay, with that, I'm a couple of minutes over, so I'm going to wrap up. Thank you very much for your time.